All right, let's dive in. Today, we're going to tackle one of the absolute cornerstones of algebra, the arithmetic sequence. Now, I know that sounds kind of formal, maybe a little intimidating, but trust me, it's something you've actually known how to do for a long time. I mean, look at this. 2, 4, 6, 8. What comes next? You didn't even have to think about it, did you? It's 10, obviously. Then 12, then 14. You've been doing this forever, since way back in grade school when your teacher called it skip counting.
See? The basic idea is already locked in your brain. All we're doing today is giving that simple pattern its official, grown-up name and uncovering the super powerful rule that's behind it all.
So here's our game plan. First, we'll nail down what an arithmetic sequence actually is. Then we'll get into the most important skill, finding what's called the common difference. After that, we'll see it in action, I'll point out a couple of common mistakes to watch out for, and then we'll wrap up with why any of this actually matters. Okay, first things first, what makes a list of numbers an arithmetic sequence? It's time to level up from skip counting and get the real algebra definition.
So, an arithmetic sequence is just a list of numbers in order, but with one critical rule. The jump, or the step, from one number to the very next one has to be exactly the same, every single time. It's that consistency that's the whole key.
And that consistent step size, it has a special name, the common difference. And in algebra, we just call it D. You can think of D as the secret code of the sequence. It's the one number you keep adding over and over again.
So if D is the secret code, how do you find it? This next bit is honestly the most crucial skill you'll need for everything we do with these sequences. And you're gonna love how simple it is. Seriously. Step 1, just pick any number in the list. Doesn't matter which one. Step 2, subtract the number that came right before it. And that's it. Whatever you get, that's your common difference, D. Now check this out. D can be positive or negative, and it works the same way. Over on the left, the numbers are going up. 8 minus 5 is 3, so our D is a positive 3. But on the right, the numbers are going down. Now watch the math here. It's 15 minus 20, which gives us negative 5. This is so important. A sequence that's decreasing just means you're adding a negative number. The rule doesn't change at all. Okay, theory's great, but let's put this into practice. We're going to run through 3 quick examples to show you how finding IDs is like finding the key to the whole puzzle. Example 1. We've got 2, 9, 16, and we want to know what's next. First job, find D. So we do 9 minus 2, and that gives us 7. Awesome. Now we just keep adding our D. 16 plus 7 is 23, 23 plus 7 is 30, and 30 plus 7 gets us to 37. Done. All right, example number 2. What about this sequence? 2, 4, 8, 16. It's definitely a pattern, right? But is it an arithmetic pattern? Let's use our rule and find out. We have to check the differences. So first, let's do 4 minus 2. That gives us 2. Okay, so far so good. Maybe D is 2. But hold on. When we check the next pair, 8 minus 4, well, that gives us 4. The difference changed. And right there, we have our answer. Since the difference isn't common, it went from 2 to 4, this sequence fails the test. It is not arithmetic. It's a great reminder that not every pattern is an arithmetic one. This one's actually called a geometric sequence, where you multiply each time instead of add. Last example. Let's say you're told the first term, a sub 1, is 100, and the common difference, D, is negative 10. How would you find the fifth term? Well, you can just write it out. Term 1 is 100. Subtract 10, you get 90. Subtract 10 again, 80. Then 70. And there it is. The fifth term is 60. Easy enough. Let's talk about a couple of common mistakes. You know, the little traps people fall into. If you know what they are ahead of time, you can just step right over them. The number one biggest mistake is subtracting in the wrong order. Think back to that sequence that was going down, 20, 15, 10. If you accidentally did 20 minus 15, you'd get a positive 5, which makes no sense, right? The sequence is going down. You have to do the next term minus the previous term. 15 minus 20. That gives you the right answer, negative 5. And the other big one, which we just saw, is assuming any old pattern is arithmetic. That doubling pattern, 1, 2, 4, 8, is totally a real math pattern, but it's not arithmetic. You've got to remember, the word arithmetic is super specific. It means you are adding the same number over and over.
So you might be thinking, okay, lists of numbers, I get it, but why do I care? Well, this idea is actually a bridge between simple patterns and some really big ideas in math, and even in the real world.
Think about this for a second. Let's say you need to know if a stack of 50 paper cups will fit under a shelf. What are you going to do? Actually stack up 50 cups and pull out a giant ruler? No way! There's a much smarter way. Check it out. The height of that very first cup, that's your first term, your a sub 1. Maybe it's 10 centimeters. And then the little rim of each new cup you add, that's your common difference, d, maybe 2 centimeters. And just like that, this everyday problem is actually an arithmetic sequence. Now you can figure out the height of 50 cups without doing all that work. But here it is. This is the big reveal. This whole idea connects directly to one of the most important things in all of algebra, linear functions. You know, that classic equation y equals mx plus b. Well, guess what? The common difference d we've been finding this whole time, it's the exact same thing as the slope, m. It's the constant rate of change.
And that brings us to one last question to tie this all together. If d is really just the slope m wearing a different hat, what does that mean the graph of every single arithmetic sequence has to look like? When you put those points on a graph, what shape do they make? Think about it. Thanks for watching.